Hello developers, welcome to Kottayat channel. In this video, we are going to build a CNN recommendation model based upon the user checking product image. For suppose, if a customer is checking for a red t-shirt, we are going to recommend him similar red color t-shirts in different shades and brands. This CNN model will be used in all the e-commerce applications. Let's see the demo first. So this is how fashion recommendation system CNN model final web application looks like. Okay, here we have an option to upload the image. Okay, let me upload an image here. So here I'm going to upload this shoes image. Okay, so once I upload the image, it is showing this is the uploaded image and it is recommending the similar images. If you see here, it is recommending the shoes only. If I upload a shoe image, it is recommending the shoes images only. Okay, and let's check for the other one. Okay, here we are uploading a image with a girl wearing a t-shirt. Okay, let's see what it is going to recommend. So as expected, it is recommending the girls wearing the t-shirts. Okay, so it is recommending the girls t-shirts. Okay, now let's check for the other one, goggles, how it is going to recommend. So it should recommend the goggles in same color almost, right, which is similar to the uploaded image. See here, as expected, it is recommending the goggles only. Okay, and let's check for the handbag. Okay, so if you upload a handbag, it is recommending the handbags, different types of models and the brands. Okay, and let's try for the watch. Here we have uploaded a analog black color watch and it is going to recommend the same analog black color watches only. Let's decode the model. First we have the 44,000 images dataset related to the fashion products. Next thing is model. In this project, we are not building any CNN models from the scratch. We are using the pre-trained model. When I say pre-trained, it is already trained on huge dataset. So we just have to import the model and configure it according to our requirements. Here we are using the ResNet50 CNN model. This model got trained on ImageNet dataset with more than millions of images. ResNet50 model can classify the images into 1000 different objects like mouse, keyboard, monitor, printer, mobile phone, etc. This ResNet50 model can extract the features from the images. When I say features, it will extract the objects inside the image. If you give a human face image as input to the ResNet50 model, it will identify the objects like eyes, nose, ears, lips, eyebrows, etc. ResNet50 model will extract the 2400 objects from a single image. Here we are going to extract the 2400 object features for each image in the fashion products dataset. So once we extract the features, we have to identify the similar images based upon the input image features. The features will be fed to the nearest neighbors algorithm. Based upon the features of the 44 images, distance will be calculated. To identify the similar product images, we will be identifying the nearest image features based upon the Euclidean distance. This is how we are going to build a fashion recommendation CNN model. And finally, we will deploy it as a web application as you guys have seen the earlier part of the video. Next thing is dataset. In Kaggle, we have two different fashion product images dataset. One with the memory of 25 GB and another one with the 593 MB. So here I am going to use the low resolution images product images dataset with just 593 MB because to download the 25 GB and to get our model to extract the features from the 25 GB high resolution images will require a huge amount of resources. So to avoid that, as it is an educational purpose project, I am going to download this fashion product images small dataset. If you have a huge amount of resources, you can download the high resolution images. Okay, I'm just going to paste this link in the description box so you guys can download it. Here is the fashion recommendation project folder. So inside this images folder, we have the 44,441 images which belongs to the fashion products. Okay, so we have all kinds of images, fashion images are there. Okay, so here is the sample folder. Inside of this folder, we have the 5 sample images taken from the entire images dataset. Okay, these images will be used as input image to see how our CNN model is going to recommend based upon this image, how it is going to recommend the remaining products. Okay, and here I'm coming back and I'm opening the command prompt, and let me open the Jupyter Lab. So our Jupyter Lab is up and running. So let's create a new Python notebook, and I'm going to name it as fashion recommendation model. Okay. So first let's install the necessary Python libraries which are required for this tutorial. I'm opening the command prompt and type in the command pip install numpy and pickle to save the model, and we need the models, right? We have to download the install the TensorFlow as well, TensorFlow, and next as Streamlit to deploy it as a web application, and we need the scikit-learn for the nearest neighbors. Okay, if you press enter, all these necessary Python libraries will be installed in a system. All these libraries are already installed in my system, so I'm not going to install them. Now it's time to import the necessary Python libraries. Importing libraries. Okay, import numpy as np short form, and import pickle to save the models, okay, in short form pickle pkl, and import TensorFlow as tf, and from TensorFlow.keras applications ResNet50 import ResNet50 pre-processed input. Okay, and from TensorFlow, so this is a ResNet50 is a pre-trained model, so we are importing it from directly from the TensorFlow keras applications. Okay, and TensorFlow.keras pre-process import image. Okay, and from TensorFlow.keras layers import global max pool 2D. Okay, and next we have imported numpy, pickle, TensorFlow, and we need to import the nearest neighbors as well from scikit-learn. From sklearn dot neighbors import nearest neighbors. Shift plus enter. Okay, something went wrong. Pre-processed input. Pre-process input. Okay. TensorFlow name. Where it is? Okay, here it is a typo. TensorFlow. Okay. Okay, pre-process. TensorFlow keras pre-process import image. Okay, so we have imported the necessary Python libraries which are required for this tutorial. As a next step, so we have the images in images folder, right? So we have to extract these image names from this folder. Okay, for that one we need the OS as well. Okay, OS module as well. Just import that OS module as well. Import OS. Okay, and file names, import file names from folder. Okay, it's not import, extract. Okay, file names will be a empty array for each and every file in os.list directory. Okay, what exactly this list directory does is it will list out the names of all the files inside this images folder. So we have 44,441 images, right? So I cannot be able to print all those images here. So I'll show you one of the image. Okay. For each and every file in this complete images, we need to extract the name of the image, right? Print file. Okay. And break. If you see here, so this is it will extract the name of the image. Okay. And we have to collect all the images names. Okay. For that one, what we are going to do is we have created a empty array file names, right? So here we are going to append this. Okay. File names dot append. Here we are just getting the file name. So we need to get the entire path images slash this file name, right? So for that one, we have another feature in OS module os.path.join with images folder and file. So we are joining both of them, and you can see print here. Let's print first this one, how it is going to look. I'll show you guys. Let me do print. So it will give us the entire path of the file. Okay. So that's what we are doing. So we have created a file names empty array. We are going to append all the list of whatever the files which are there in the images folder. For 44,441 images, it will repeat that entire loop. So what we are doing is we are extracting the entire file image path. Okay, we are extracting here the entire image path. Okay, and let me remove this one, and I'm just removing this comment, removing the break as well. Okay, let me execute it. Oh, somewhere extra. Okay, it's done. Now see the file names of 0. So this is how it will extract the images path. Okay, let's see how many images are there. Home length of this complete list. So it should give us the 44,441 which are there in our images dataset. Okay, so now we have extracted all the file names. Okay, so once we extract the file names, the next step is here we are going to create the model. Here we are going to import the model. We are not creating the model, we are importing the model. Importing ResNet50 model and configuring it. And configuration. Okay, so here we have to import the model. Model is equals to ResNet50 model. Here we have to give the first parameter as weights as ImageNet. So as I told you earlier, as I said earlier, ResNet50 got trained on the ImageNet dataset, right? So we are importing that model which got trained on the ImageNet. So that's the reason we are passing the parameter weights as ImageNet. Okay, and include top. So we are including top is equals to false. So that means we are excluding the one of the layer, top layer from the ResNet50. We are going to replace it with our own layer. Okay, that's what include top is equals to false. And the next thing is input shape. So input shape should be 224 pixels and in 3 colors. Okay, RGB. So whenever any image, when we have given it to the model, so it will be treated it as a array. Okay, NumPy array, and with the 3 different shades. Every color will be in the world has been classified into the combination of 3 colors: RGB, red, green, blue. So that's the reason 224 pixels height and 224 pixels width in 3 shades. Okay, RGB colors. And that's what we have imported the model. And next step is we have to add the top layer which we have missed, right? And before that we have to pass one more thing. Model dot trainable is equals to false. We are not training the model, we have already making use of the already trained model. So that's the reason we are setting the parameter trainable is equals to false. So we are not training the model, we are just making use of the already trained model. Here we have not included the top layer of the ResNet50, right? As I said earlier, we are going to replace it with the global max pool 2D layer. Okay, that's what we are doing the next step. Model is equals to tf dot keras dot models dot sequential model. Okay, here model, and next thing which we are passing here is global max pool 2D layer. Okay, it's our own layer. Now let's print the summary of this model. Model dot summary. Okay. See here, we have created a sequential model, and one of the layer is ResNet model with output shape as 772048. Okay, and if you see here, when we added the global max pooling 2D, it has been converted into 4-dimensional array to 2-dimensional array. Okay, with just 2048 the features of the image. Okay, that's why we are using the global max pooling 2D. Okay, and if you see here, total it is having 2358771 parameters, and all these parameters are the total parameters, and trainable parameters are 0. Okay, we are making use of the already trained parameters. Okay, that's what it is. We have created the model. Now we have to extract the features from the images. Okay, and let me do one thing. Let me take one of the image from the sample folder and going to copy paste it here. Okay, and here is the image. Now we have to extract the 2400 features from this image. Okay, let's see how we are going to extract that. Okay, by using our model. Okay, extracting images from features, extracting the features from image. Okay, first we have to read that image, right? Image is equals to, if you see here carefully, we have imported this pre-processing of the keras. Okay, image module. So we have going to make use of that image model here. Okay, image dot load image. We are going to load the image. This is the image, right? Just copying the path here and pasting it. Okay, and next we are going to see here is next thing is target size. So target size we are going to give 224 comma 224. Okay, so whatever the image which you provide, it will be converted into 224 pixels height and 224 pixels width. Okay, so that's what our model is expecting. So 224 versus 224. Okay, and next thing is, see that image. This is the image. Okay, we have read the image in 224 pixels height and 224 pixels width. Next thing is, we have to convert it into array. Okay, now image array is equals to image dot image to array. Okay, we are converting this image to array. Okay, we are passing the image as input. Now let's see this image array. So this is the numpy array of the images when it converted to array. Okay, and you can see the shape of it as well. If you see here, the shape of this image is converted to 224 pixels height and 224 pixels width in 3 color shades, RGB. Okay, we have converted the image to array, right? Now the next step is, our ResNet model got trained on the batches of images, so it will be expecting the batches of images input. But here we are giving only one image as input to extract the features, right? So what we have to do is, we have to reshape our image array. Okay, that's what we are going to do. In numpy array, we have a feature called the expand dimensions. By making use of that expand dimensions, we are going to convert the shape of this image array. Okay, image expand dimensions equals to np dot expand dimensions for image array, and axis is equals to 0. Okay, and if you print this shape of it, if you see here, it converted from 3D array to 4D array. Okay, one image and this array. Okay, so we have converted this 3-dimensional array to 4-dimensional array, which is ready to feed it to the model, but we cannot directly load this to the model. Okay, if you see here, there is another feature which was coming with the ResNet50 pre-process input. So before feeding the image array to the model ResNet50, we have to apply the pre-process input. So it will convert that image data into from RGB to BRG, combination of R, red, green, blue, to it will convert to blue, red and green. Okay, that's what that pre-process input does. It comes up by default with the keras. Okay, that's what we are going to make use of the pre-process input here. Okay, so I'm converting this image dimension to pre-process input. Image pre-process. Okay, we are going to pre-process the image by passing this image expand dimension array. Okay, pre-process input image expand dimension. Okay, see how it is going to be. Yeah, same image, but it will be converted from combination of RGB to BRG. Okay, that's what it does. And next thing is we have to fit it to the model, right? Result is equals to model dot predict. Okay, our model is going to predict. We have to pass this. Okay, pass this one. Give us the, it will extract the 2044 features from the image. So here is the data set. Okay, let me print the shape. If you see here, it extracted the 2048 features from a single image, which we have given 16871. Okay, and we can flatten this one like this. Okay, if you see here, it has extracted the 2048 features from an image. Okay, let me print that result. They're not able to see it. Okay, it will be in numbers. Okay, so once we get this number, if you see here, the numbers are from 2048. It is having 0, 0, 0, 2, 5.99, 1.13. So we need to, what we have to do is we need to scale this array, okay, in between 0 and 1. For that one, we are going to use the concept called the we haven't imported, so we have to import the one more concept from numpy array, which is from numpy dot linear algebra import norm. So we are going to make use of this norm. Okay, no module name. Okay, how we have, okay, we have to convert this, we have to scale this extracted features between 0 and 1 with the norm. Okay, for that one, what we are going to do is normalized result is equals to total result divided by the norm of the result. Okay, we are going to use that. If I print this norm result, we'll be able to see that the data has been scaled between 0 and 1. Okay, if you see here, the earlier the result was 0, 0.83 and 2.3. If you see here now, 0, 0.02, 0.002, all that, it has been scaled between 0 and 1. So that's what the normalized result does it. Okay, so this is how we have to extract the features from the images. Okay, we have extracted the feature from only one single image. Now we have to extract these features for the entire images data set. Okay, now what we are going to do is, instead of doing it once and twice, what I'm going to do is I'm just going to make a function out of this one. Okay, and just copy it and pasting it here. I'm just going to write the function extract features from images. Okay, it will take image path as a input and model. Okay, so it has taken these two, same process has to repeat. Okay, and instead of here I have to return this result, right? Return. Okay, and here instead of passing it as a static image, we are going to replace it with the image path. That's it. Okay, okay, we have printed it. Now extract the features from the images for the original data set. Okay, file names, let me just check for the first image. Okay, how it is going to be, file names of 0, comma, model. Okay, we have extracted the features from one single image. Now we are to repeat this entire process for all the images. So for that one, I'm going to write a loop here. Okay, for file names. Okay, here I'm going to create an empty array as well. Okay, image features. Okay, we have to append this array with the all the files features. Okay, all the image features. Image features dot append with the extract features from the images by passing the image path and model name. Okay, and let me apply a break here. We are repeating the loop only for the one image, so we just wanted to see whether it is working fine or not. I don't know, it's taking longer time than usual, so let me stop it and re-execute from starting. Okay, See here it has been extracted the features for one image. Okay, and let me just check for 5 images. Okay, and let me remove this break here. Okay, so we have extracted the features from the first 5 images. For 5 images, it took 2 to 3 seconds of time. But we have the 44,441 images are there in our dataset. To extract the features from the entire dataset, it is going to take a longer time. For me, it took like 1 to 1.5 hours because my laptop resources are really good. If you are using a normal laptop with the normal resources, it is going to take a longer time. Okay, due to the duration of the video, I have already completed this step. For you, if you are executing it for the first time, you just have to go through this complete process to extract the features from all the images data set. Okay, I'm going to provide this notebook. Okay, you just have to just execute it. I'm just going to remove this filter and I'll give this notebook to you. Okay, you guys can execute when you are executing the first time. You just go through this complete extracting the features from the complete data set. Okay, as a one-time process. Once you extract the features, what you are going to do is we have to save those features, right? So with the make use of the pickle, we are going to save these features. Okay, how we are going to save here is image features is equals to pkl dot dump of, and here we are using the image features array, right? So these features, this should be saved. Okay, then open images features dot pickle with write binary access. Okay, similarly we have to save the file names. Okay, file names is equals to, here we have to save the file names. Okay, and file names dot pickle. Okay, just executed both. If you see here, file names dot pickle and images features dot pickle file has been created. Okay, when it comes to the images features, we have extracted only the features for the only first 5 images features only extracted. Okay, but if you are running it for the first time, you have to repeat it for the entire data set. Okay, I just said earlier, I have already completed this step. Okay, so I'm going to replace this images features dot pickle with this file with the my own file. Okay, but when you are running it for the first time, you just have to repeat this entire process for the entire data set. Okay, I have replaced this images features.pkl file. If you see here, the size of the file is 357 MB. Okay, now we have the images features and file names, right? We have dumped here, but we have to open these files, right? Once we dump them, we have to open them. So the next step is just copy this step, loading pickle files. Let's add a step as loading pickle files. Okay, and in images features, instead of dump, use the load option and remove this option. Instead of write binary, make it as a read binary access. Okay, same step for the other one as well. Okay, file names start pickle. Okay, images features and file names. Okay, let me print the shape of this image features. Okay, shape. Okay, it's not a numpy array. Let me convert it to numpy array. np dot array of features. If you see here, this image features will be containing the 2048 features for each image. We are having the total 44,441 images, right? So 44,441 images, 2048 features has been stored in this image features dataset. Okay, we have extracted the image features for the entire dataset. Now the next step is we have to find out the distance, right, with the nearest neighbors. Okay, let's do that. Finding the similar images. Okay, let's find the similar images with the nearest neighbors. Okay, here we have to create neighbors. Okay, nearest neighbors by passing the neighbors as we need the 6 images. So here we have given the n neighbors as 6. The reason why we have given 6 instead of 5 is the first image will be the self image. Okay, from then onward the next 5 images will be coming, right? 1 plus 5, that is a 6. We have to exclude the first image because it will be a self image. Next thing is we have to have a algorithm is equals to brute force algorithm we are going to use here, and metric is equals to Euclidean. Okay, we have created the neighbors model. Now we have to fit it with the images features. Okay, neighbors dot fit with the images features. Okay, so we have created the nearest neighbors. So we have created the nearest neighbors with the image features. Now the next step is we have to find out the similar images, right? So we need an input image. So we are going to make use of this image as an input image. 1687, this goggles as a input image. Okay, let's do that. For that one, input image is equals to, we need the features for this image. For that one, we have already created a function, right? Extract features for images. So we are going to make use of that function. Extract features from the images, and we have to pass this image path. Okay, so going to copy and paste it. Sorry, copy the path, pasting it. Okay. Okay, we have to pass the model as well. Okay, we have extracted the features for the input image. Now we have to find out the nearest distance images, similar images based upon the features. Okay, for that one we are going to use the neighbors dot k neighbors. Okay, and here we are going to give the input image. Okay, it gives us the two values, distance and indices. Okay, let me print the indices. So these are the 5 images which are related to 16871. Okay, 2 3 4 5 6 7 1 2 3 4 5 6. Okay, and okay, now let's see. Let's print these images. Okay, for that one we have to import the IPython module from IPython dot display import image. Okay, and for that image we have to pass the input image first. Okay, this input image. Okay, copy path. This is an input image. Now this is the input image, right? Now we have to find out the file names for these indices. Okay, with the help of the file names. Okay, the list, we have the file names list. Okay, for that one what I am going to do is file names of indices of 0 0. Okay, this is the image path. Now we have to pass it to the image. Okay, image. See here, as I told you earlier, the first image is going to be a self image. Okay, the next one we need. Okay, this is the one image, and this is the second image, and this is the third image, and this is the fourth image, and this is the fifth image. Okay, when we give this image as input to our model is recommending these 5 images because which are very similar to the input image which we have given. So our model is really recommending the images which are similar to the input image which we are giving. Okay, now let's see what we have done so far. Okay, so first we have imported the necessary Python libraries. Next thing is we have extracted the file names from the entire folder, and we have 44,441 file names are there. Now here we have created a ResNet CNN model with the weights. We are importing the weights of the ImageNet dataset trained model, and we are not including the top layer. The top layer is going to be the global max pool TD, and we are giving the input shape as 224 224 3. Okay, and our model is not trainable, so that's the reason we have set it the flag to false. Okay, we have created the ResNet CNN model. So once we created the model, we have extracted the features for the each and every image, right? For that one we have created a extract features from the images. Okay, first we load the image with the target size as 224 224, and we have converted it into the array, and then we have converted into the expanded the dimensions because ResNet model got trained on the multiple batches of images, so it is expecting the input image as a batch. So that's the reason we have expanded the dimensions. And next thing is the expanded dimension is in the form of RGB. So for the ResNet model it needs the BRG, so that's the reason we are using the pre-process input here to convert the RGB configuration to BRG configuration. Okay, and then we are predicting this extracting the features for the image, and we are flattening that array, and we are normalizing the result. Okay, we have extracted the features for the first 5 images due to the duration of the video. when you are running it for the first time, just remove it and then you guys can continue the process. Okay, so once you extract the features from the images, we have to save them here. Okay, image features and file names with the pickle as images features.pickle and file names.pickle, and then whenever you want you can load those image features.pickle into the images features with the pickle module. Same goes for the file names as well. If you see the shape, so 44,441 images features has been extracted. Okay, and now we are making use of the nearest neighbors to find out the nearest images based upon the input image. Okay, by using the Euclidean distance. Okay, here we are extracting the six nearest neighbors. Okay, we are using the algorithm as a brute force and the method is Euclidean. So based upon the Euclidean distance, we are going to identify the nearest six images from the based upon the features. Okay, and we are training these neighbors with the images features, and after that we are extracting the input image features and we are passing it to the k neighbors, and it is recommending these are the images indices. It is giving the indices of the nearest images and we have to pass it to the file names to print those images. Okay, we have done it till this step. Now the next step is we have to take it to the next level by developing a web application, as you guys have seen the earlier part of the video. So let's jump into the Visual Studio for that. Okay, I have opened our project folder in the Visual Studio. Okay, now I'm going to create a new file called app.py. Okay, don't worry guys, I'm going to share this entire code with you guys. Please do check in the description box. I'm just going to give the link of this entire code. Okay, and here we have to import couple of things. So I'm just opening this fashion recommendation model Python notebook, just copying and pasting it here. We need pickle, we need TensorFlow, we need the nearest neighbors, we need the OS, we don't need the, yeah, we do need this norm as well. Okay, and addition to that we need the Streamlit. Okay, by using the Streamlit we are going to deploy it as a web application. Okay, and st.header as fashion recommendation system. Okay, save it. Okay, let's run this file. Okay, opening the terminal. Okay, so whenever you want to run any Streamlit app, so the command is Streamlit run and the file name. Okay, and if you press enter, it will open a new tab in your browser where this application is being running. Okay, so application is running here, so fashion recommendation system. And whenever you are making the changes, go to the settings here, run on save. So whenever you make changes to the source file, it will automatically get refreshed. Okay, you don't have to do the refresh manually every time when you are making changes to the source file. Okay, and okay, just removing this one. Okay, we have the fashion recommendation, so we have to copy some code from this notebook. Okay, let's go back to the down. We need these ones. We need the image features first and to be loaded, and the file names as well. Okay, so once we have these two, the next step is what else we need. So we need this function as well to extract the features for the input image. Okay, we have extracting the features from the input image. Okay, after extracting the input features, we have to pass it to the model, right? And predictions and all that stuff should happen. Anything else that do we need to copy? Image copy. We need to copy this one as well, the model as well. Okay, just removing this model.summary. Okay, saving it, and yeah, now let's write the Streamlit code to upload a file. Okay, and upload file is equals to Streamlit dot file uploader uploaded image. Okay, upload image. Okay, it's running. Okay, here it is coming. Okay, if I open any image, okay, it's 2500.jpg. Okay, we have to save this image. Whenever user uploads an image, we have to save it. Okay, first for that one, what we are going to do is, if upload file is not none, okay, we have to save the file, right? So we have to save the file. For that one we have to write the code, okay, Python code with open, okay, os.path.join, okay. We are going to save them in the create a new folder called upload, okay, to save into the upload folder, okay, comma with the upload file the same name, okay. We have to open this file with the write binary access as f, okay, and f dot write f dot write with the uploaded file dot get buffer, okay. So let's see what we have written here, okay. First what we are doing is we are asking the user to upload an image, okay. This is streamlit code. So once the user uploads the file, so the file name will come here, okay. We are checking whether the user has uploaded a file or not. If user has uploaded a file, then what we are doing is we are saving it into the upload folder. That's what we are doing, upload folder with the name of the file, okay. With the write binary access we are opening the file and we are saving it here, okay. Let's check it out. Saving it, coming here and browse the files, and let me take this one, open. If I come here, if I check in the upload folder, yeah, if you see here the image has been uploaded already, okay. It's been already available in the upload folder, okay. And let me try for the another file, shoes, okay. Let me check in the uploaded folder. Let me refresh. Yeah, see here this image also uploaded, okay. So we are saving this uploaded images, okay. The next step is we have to display that image, right? First display image the upload file dot in, okay. And what we have to do is to do the st dot subheader of subheader of uploaded image, okay. Now let's see that, rerun it. Okay. Let me change it to uploaded file, not with the name, okay. It's refreshing. Yeah, if you see here it is showing the uploaded image, okay. If I upload this handbag, it should display the handbag now. Yeah, okay. So whenever user uploads the image, it's taking it and it's saving it and it's displaying it here, okay. So once that is done, the next step is we have to extract the features from this uploaded image, right? So for that one we have to use this one, okay. Input image features equals to extract features from the image, okay, not this one, upload file, okay. We are extracting the features from the user uploaded file and we are saving it to the input image features. Now we have to pass it to the model to predict, okay. Here we have to pass the model as well, okay. And we have created the nearest neighbors as well, right? No, we haven't created. We have to copy paste that nearest neighbors as well, okay. Where the code for the nearest neighbors, yeah, here it is. Nearest neighbors and copy code, and here we are going to fit it, okay. And here to identify the indices, right? Okay. We are extracting the here and this is what we need, okay. We need the indices, okay, distances and indices here, input, okay, input image features, okay. We have copied the necessary code. Now we got the indices, okay. Now we have to find out we have to display these indices, okay. For that one I'm going to write st subheader recommended products, okay, recommended images, okay. and we have to display those images, right? st dot image of file names of instead of 0, and we have to explore the first one, right? This is all. Okay, and let me see here. Yeah, if you see here, this is the one of the recommended images for this bag. Okay, we have to display the rest of the 4 images. Okay, so we have to display the images side by side, right? For that one, we have to create the columns in the streamlit. Okay, for that one, column 1, column 2, column 3, column 4, column 5. We need the 5 columns for the 5 images to be displayed. Okay, st dot columns. Have to pass the 5, the number of the columns we need. Okay, now with column 1, this is what it is going to happen, and same thing goes for the column 2, column 2 and 0 comma 2. Okay, let me save it and see here. Yeah, it is displaying the 2 images. Okay, now let's repeat the same step for the rest of the columns. Okay, column 3 and index is going to be 3, column 4 and index is going to be 4, column 5 and index is going to be 5. Okay, saving it. Okay, these are the 5 images it is showing. Okay, so this is how fashion recommendation system CNN model final web application looks like. Okay, here we have an option to upload the image. Okay, let me upload an image here. So here I'm going to upload this shoes image. Okay, so once I upload the image, it is showing this is the uploaded image, and it is recommending the similar images. If you see here, it is recommending the shoes only. If I upload a shoe image, it is recommending the shoes images only. Okay, and let's check for the other one. Okay, here we are uploading a image with a girl wearing a t-shirt. Okay, let's see what it is going to recommend. So as expected, it is recommending the girls wearing the t-shirts. Okay, so it is recommending the girls t-shirts. Okay, now let's check for the other one, goggles, how it is going to recommend. So it should recommend the goggles in same color almost, right, which is similar to the uploaded image. See here, as expected, it is recommending the goggles only. Okay, let's check for the handbag. Okay, so if you upload a handbag, it is recommending the handbags, different types of models and the brands. Okay, and let's try for the watch. Here we have uploaded a analog black color watch, and it is going to recommend the same analog black color watches only. So this is how the fashion recommendation CNN model works. Okay, when you upload an image, it is going to extract the features from that image, and it is going to based upon the features of the image, and by calculating the Euclidean between the rest of the images, and it is going to recommend the similar images. Okay, so our fashion recommendation system model is working as expected. If you like the content in this video, please do like and subscribe to our channel. Thank you. Thanks for watching this video.